Keep in mind, this request object is the object Node.js generated for us with all the data of the incoming request when we visited localhost 3000, which we in turn can do because we listen to requests on that port. So this is the request object. If we have a look at it, we see it's a very complex object. There's lots of data in it. It's not just data. These are also partly functions we can call and so on. So this is quite a complex object. But we also see that, for example, we have some headers here. Headers, as I mentioned earlier, are metadata, meta information added to a request and also to responses, by the way. And there we see, for example, the host this was sent to, the request was sent to. We saw some headers attached by the browser, like, for example, how the response data should be cached and stuff like that, which browser we used for that request, which kind of response we would accept, that we accept some HTML, XML, and so on, that we would accept encoded responses, so where the response is actually minified to, well, save bandwidth, and so on. There also was a cookie attached even. We haven't learned about cookies yet, we will so later, but this was attached to some Google Analytics cookie. We saw which HTTP version was used, and so on. So there's a lot we can gain from that request, but a bit too much. Now, there are only a few important fields you typically need. The first important or interesting field is the URL. Let's output that, and let's also output, you can output more than one value by separating them with commas, request method, and also request headers here. Let's output these three values and restart the server with Node app.js. So now it's again listening, and let's reload that page on localhost 3000. If we do so, now we see the output has changed. We still have all the header stuff because we're outputting request headers. But prior to that, we output the method, which you see here. It's get. And you see the URL. And the URL is just a slash here because the URL is basically everything after our host. And we just have localhost, well, nothing. And that basically translates to localhost slash. If I had slash test, now we see another output. And there we see slash test being logged here. And then also get for the method and our headers. So this is basically how we can access some information about our request. Now, one crucial thing that is missing here is the response. So let's have a look at sending responses in the next lecture. In the last lecture, you saw how to handle requests and how to read some data from the request, like, for example, the URL and which HTTP method we used. Now we'll learn about different HTTP methods throughout the course, by the way. Get is the default method used if you just enter a URL into your browser. Let's now shrink this again. Let's quit the server. You always need to quit and restart if you edit it, because otherwise your changes will not be reflected, because the old process will still be running. And let's now also use that response object. Now we could log that with the console, but actually this does not hold any interesting data. Instead, we can use it to fill it with data we want to send back. We do this by calling res, and now what? There are a couple of methods we can use. For example, set header. This allows us to set a new header. For example, content dash type, and that is a default header which the browser knows and understands and accepts. And then as a second value here, as a second argument in set header, we set the value for this header key. And we can send this to, or set this to text HTML. Now what this will do is it will attach a header to our response where we basically pass some meta information saying that the type of the content which will also be part of the response is HTML. Now there is of course only a certain set of supported headers the browser understands. And after this lecture you'll find another lecture with some link where you can learn which headers you can set. Now you don't need to set that many, let me say that. And later we will even learn about a package that does this for us so that we don't have to set the content type on our own. But here I will set it. Now, one important thing is missing, of course, and that is the HTML code, right? Thus far, I'm saying we have HTML code, but I'm not sending it. Now, we do this by setting response, and now we can set write here. Write allows us to write some data to the response. And this basically works in chunks, you could say, or in multiple lines. This would be a good picture to look at this. You write multiple lines of response. For example, if we write HTML code like this, res write. And if this looks super strange now, it is. We'll learn about a way easier way of sending HTML later, no worries. So here I'm just sending HTML, and you can also put longer HTML in there. Of course, you could now have your head, where you set the title, my first page, like this. And you could put even more into that line, but to make it easier to read, I'll write a new line where I now have my body. So I'm basically writing a whole HTML document here in a very complex way. And there I'll just add a h1 tag saying hello from my Node.js server. Okay, so this is now some HTML code, and it will be written to the response line by line. We now also need to tell Node once we're done with creating that response. And we do this by calling end. So after we set all the headers and wrote all the data to the response body, we call end, and now is the point where we must not write anymore. We can still call write, but this will result in an error because we must not change the response after we ended it, because this is basically the part where we will send it back to the client. Node.js will send it back to the client. So here it should send back a response with some HTML code inside of it, where we also tell the browser that it's HTML code. The browser wouldn't know otherwise. And with that, if we save that file, make sure you never forget to save your changes, and we re-execute it, we again have that running process. And now, if I reload my localhost 3000 page here, we see hello from my Node.js server. And if I open the Chrome developer tools here, which you can also do from the menu, I use the shortcut. You can also use View, Developer, Developer Tools, or that shortcut you see here. Now, if you do that, let me reload. In the Network tab here, you will see this request, this first request, and there you see headers, like, for example, in response headers. There you see my content type, which I set, right? This is the header we set here. And if we click on response itself to see the response body, we see that HTML document code we wrote with the head section, with my first page, and so on. So this is now how we can send a response. We'll later also learn about a way simpler way of doing that by using the Express.js framework. But it's super important that you understand all the nitty-gritty details that go on behind the scenes. And in this case, we simply understand it by writing all the nitty-gritty code on our own. This is how we can work with requests and send responses. Now let's connect both the request data we can get and the response data we can send. In the last lectures, we learned how to spin up that server, and that we got a request object with information about the incoming request, and a response object that we can use to send back a response. Let's now connect both request and response. Instead of printing some request data to the console, which of course doesn't do much for us, let's instead start writing a very simple web server that does different things depending on which route we enter. So depending on which / whatever part we enter here. So let's say for /nothing, we want to load a page where the user can enter some data, which we then store in a file on the server once it is sent. We can do this by, first of all, parsing the URL. I'm storing it in a new constant. And I do this by accessing request URL. Remember, that was something like //test, whatever we entered. I will then add an if statement and check if URL is equal to just slash, and only this will match. By the way, the triple equal sign means that this will only be true if URL is both a string and has that value. So now here, if that is the case, I want to return a response which holds some HTML that gives the user an input form and a button that will send a new request in return. And that will not be a GET request, by the way. So let's do that step by step. Let's copy this code here and put it into this if statement. And here I will write a HTML document with a head, maybe a different title, enter message, and the body will now not hold a h1 tag, but instead a form. This is a default HTML element, of course, with an input of type text, let's say, and a button. And this will be super ugly because we have no styling, but it's about the functionality for now. That button tag must be closed, by the way. The button will be of type submit, so that it submits the form, and that will be some default HTML behavior we're using here, where a button with type submit in a form element will send a new request, and we'll configure that request in a second. Let's first give the button a caption, send, and now on that form element here, we add an action, which is basically the URL this request, which will be generated automatically, should be sent to. And I will use /message here, and this will automatically target the host it's running on, so localhost in our case here, localhost 3000 to be precise. And then we define the method, the HTTP method that should be used. And there we previously saw, if we expand this, that we got a GET request, which is the default if we enter a URL. Well, here we're not entering a URL. Instead, we want to send a so-called POST request. There is a limited set of HTTP verbs you can use. GET and POST are the two most important ones. A GET request is automatically sent when you click a link or enter a URL. A POST request has to be set up by you by creating such a form. There also are some other ways by using JavaScript, but we'll ignore them for now. So in HTML, we create such a form and we define that the method should be POST. And this will send a POST request to /message. And the cool thing about form is it will not just send such a request, it will also look into the form, detect any inputs or related elements like selects we might have. And if we give that input a name, which we should, message, it will also automatically put that message into the request it sends to our server. So now here, when we visit just localhost 3000 /nothing, we will return a response where we render this HTML code. Now let's also put a return statement in front of resEnd. This is not required to return a response, but to return from this anonymous function and to not continue this code, because we return prior to it, and this will quit the function execution. And we must do this because I told you that after resEnd, we must not call any other resWrites or resSet headers. But this would happen if we not return, because then it would just continue execution with these lines. I don't want that. If we make it into the if statement, we should also quit here. We should exit out of this function. With this, let's restart the server by quitting it with Ctrl+C and restarting it with Node app.js. And let's reload this page on localhost 3000 /nothing. And we see my input and the send button here. Again, not super pretty, but it's working. Now let's make sure that if we enter something where we hit send, we see this, that we now not only see this, but that something else happens. By the way, we do see this because now the URL is /message, and /message does not make it into this if statement, and therefore this code runs. But we want to do something else, so let's do that in the next lectures. So we made sure that we listen to requests to just /nothing and that we return some HTML code with our input field on it. Now when we click that send button, we send a post request to /message, but we're not doing anything with that. Time to change that. Let's add another if statement here. And let's check if the URL is equal to message, and let's add another condition. And that condition is that I want to be sure that we're not handling a GET request but a POST request here. So let's also parse the method from request method and make sure that method is equal to POST. Now we'll only enter this if statement if we have a post request to /message, which happens to be exactly what we create with this form. In this case, I want to do two things. I want to redirect the user back to /nothing, so not leave him on /message, and I want to create a new file and store the message the user entered in it. Now, this involves a couple of things. Let's start with redirecting and creating that file. We actually already worked with a file in the first course section. And do you remember how that worked? Feel free to go along on your own if you know that. We need another package, another core module, and that was the file system core module. So let's import it by storing the functionality in a constant. You can name it however you want. I'll name it fs because the package is named fs. But you can also name this differently. Not the package, just the constant. So fs allows us to work with the file system. And here I now want to write a new file. So here let's execute write file. And write file takes a path to the file. And I'll just use the file name to create it in the same folder as app.js. And I'll simply name it message.txt. And in there, I obviously want to store what the user sent. Now this is a little bit more work, so for now, let's just put some dummy text in there. And let's redirect the user. Now important, we should actually use write file sync for now. And I'll explain what the difference to write file, which also exists, is in a while. So let's use write file sync for now. Now write head, which basically allows us to write some meta information in one go. And then we set a status code of 302, which stands for redirection. And then we pass a JavaScript object with some headers we want to set. And you could also do this in 2 steps, by the way. You can also set the status code to 302 and then simply have set header. And there we set the location. This is also a default header accepted by the browser. And we set that location to just / and it will automatically use the host we're already running on. And then we have to call res and important, as before, return this so that we don't execute these lines. Otherwise, we'll get an error. Now let's restart our file here. And make sure to go back to /nothing and reload that page with the input field and send any value, and you should simply reload that in the end because you get redirected here. But you can see that redirect here in the network tab of the developer tools. Here 302 indicates we sent a request to message and we were redirected to localhost. So this is working, and we also got the message text with dummy inside of it. Now let's also get rid of that though. And let's work on actually parsing the data the user sent us and writing that data into that file. So time to parse the incoming request and get the data that is part of the request, because that data should be whatever we entered here. Now, how do we get access to that? Well, we got request URL and request method. You might think there is something like request data, but there isn't. Instead, the incoming data is basically sent as a stream of data. And that is a special construct JavaScript in general knows, but Node.js uses a lot. Now, what is such a stream of data, though? There is a connected concept, buffers, and we'll have a look at both here. So let's take our incoming request as an example. There also are other streams, like for example when working with files, we can also work with streams, but let's stick to requests here. Our stream here is basically an ongoing process. The request is simply read by Node in chunks, you could say, in multiple parts. And in the end, at some point of time, it's done. And this is done so that we theoretically can start working on this on the individual chunks without having to wait for the full request being read. Now, for a simple request like the one we're working with, this is not really required. We only got one input field data. It doesn't take so long to parse that. But consider a file being uploaded. This will take considerably longer, and therefore streaming that data could make sense because it could allow you to start writing this to your disk, so to your hard drive where your app runs, your Node app runs on your server, whilst the data is coming in, so that you don't have to parse the entire file, which is of course taking some time, and you have to wait for it being fully uploaded before you can do anything with it. But this is how Node handles all requests, because it doesn't know in advance how complex and big they are. So you can start working on the data earlier. The problem is, with your code, you can't arbitrarily try to work with these chunks. Instead, to organize these incoming chunks, you use a so-called buffer. A buffer is like a bus stop. If you consider buses, they're always driving. But for users or customers being able to work with them to climb on the bus and leave the bus, you need bus stops where, well, you can interact with the bus basically. And that is what a buffer is. A buffer is simply a construct which allows you to hold multiple chunks and work with them before they are released once you're done. And you work with that buffer. Now that's pretty abstract, but it's pretty easy to work with, fortunately. So let's see how that works in practice. When receiving a posted message, before sending the response and before writing to the file, we want to get our request data, right? And we do this by going to our request and registering an event listener. We haven't done that thus far, but as I mentioned, Node uses these heavily. For create server, it implicitly creates one for us. Now we do this on our own by using the on method. Now on allows us to listen to certain events. And the event I want to listen to here is the data event. You see my IDE even gives me some help here and tells me which events I can listen to for a request. So here I want to listen for the data event. The data event will be fired whenever a new chunk is ready to be read. You remember that buffer thing? This is basically helping us with that. Now here we have to add a second argument, which is that function that should be executed for every data event. You remember create server? It had a similar concept. There we defined a function that should be executed for every incoming request. Now we're defining a function to be executed for every incoming data piece. So here I'll again use a ES6 arrow function. You could also use the function keyword without that arrow then. And as you can also see on data, this listener receives a chunk of data. So here we receive a chunk. And this chunk is something we can work with here. And now we have to do something with this chunk to be able to interact with it. For this, I will create a new constant here. And I'll name it body because I'll try to read the request body. You can name it however you want, but it is the request body we're working with. Now the body should be an empty array. And now in that function here, in the data event, I'll take my body and push a new element onto it. By the way, if you're wondering how we can edit a constant value, this only means that we can never reassign a new value. So we can never use body equals something again. But with push, we're changing the object behind that body element, that body object. We're editing the data in that object, not the value itself, not the object itself. It's a bit strange to wrap your head around, but this is in the end how it works. So we can now push a new element into this array to make it non-empty, and we push our chunk here. Now, Node.js will execute this so often until it's done getting all the data out of our request. That can be once, that can be multiple times. And we can even log this to see how often it does this and what's inside of this chunk. Now we need to register another event listener, and that is the end listener. This will be fired once it's done parsing the incoming request data, or the incoming request in general. Here it will again execute a function we define as a second argument. And in this function, we can now rely on all the chunks being read in. And they're all stored in the body now. Now, to interact with this, and don't forget the comma after end, to interact with that, to work with all these chunks, we now need to buffer them. Remember that bus stop concept? We got all these chunks. We now need to do something to be able to work with them, to basically have one place where the bus stops and we can interact with it. So here, I'll now create a new constant, parsed body. And there I will use the buffer object, which is available globally, made available by Node.js. And I can concat my body. So this will in the end create a new buffer and add all the chunks from inside my body to it. And then on this buffer, which I got here, parsed body is now a buffer. There I can call toString to convert it to a string. So this is a utility method offered by Node.js where we do something to our buffered chunks. Remember, the bus is now waiting and the bus stops, so to say. The buffer is our bus stop. And now we do something with it. Here we convert it to a string. And this only works because I know that the incoming data will be text, because the body of that request will be text. If it were a file, we would have to do something different, but it is no file, and I know that it isn't, because we're writing the code, we know what we will receive, right? So this is the parsed body. And this is now finally what we can work with. So let's also output the parsed body. This was a lot of talking, so let's simply have a look, quit the server with Ctrl+C and restart it, and then send another request with some message here. And now, if you have a look at what's being logged, you see two elements. The first one is coming from this console log, and you see that is a chunk. That is a chunk we can't work with. But now the parsed body receives or yields this line, and that is something we can work with. And its message equals something because we named our input here message, and as I said, that form will automatically send a request where it takes all the input data and puts it into the request body as key value pairs, where the names assigned to the inputs are the keys and the values are what the user entered. And that is what we have here, a key value pair separating the key from the value with an equal sign. Now, and with that, we can now work with that and finally store the input in our file. And we can do that here in request on end to be precise, by creating a new constant message, taking the parsed body and splitting it on the equal sign, and then taking the element with the index 1, which is the second element in the resulting array, which is the element on the right of the equal sign. And now we can move write file sync into the end function. We don't want to execute it here because this will actually run before this function is called, because here we just register a function to be called in the future. It's not executed immediately. Remember, Node doesn't wait and pause. It will not block the script execution. It just registers this as a to be executed action and then right away continues. So if we have something that depends on the incoming data, we have to move it into the event listener too, so that it's also part of the to be executed code sometimes in the future and doesn't run too early. And now we can write message to the message.txt file. Let's now restart this file one more time and enter hello here and hit send. And now if you look into message text, we see hello. You see the exclamation mark was encoded. Now that is something we can worry about later, but in general, this worked just fine. And if you're now totally frightened by how complex Node.js is, this is the raw logic. We'll later use Express.js, which hides all that raw logic. But to understand why we use that, you first of all need to understand what is happening and why using tools like Express.js, which will make all of this much easier, are great. So with that, we got our basic logic down. Let's now dive again into that event listener and writing files thing, because there is something really important you have to understand. We already achieved a lot in this section, and I know that all this code looks kind of intimidating. And no worries, it will become much easier, but I find it super important to learn it the hard way first so that you never forget what's happening behind the scenes. Now, one crucial thing which I know that people often struggle with is that the order of execution of your code here is not necessarily the order in which you write it. For example, this here will actually execute after this code. So it will even execute after we already sent the response. This has two important implications. For one, sending the response does not mean that our event listeners here are dead. They will still execute even if the response is already gone. But it also means that if we do something in the event listener that should influence in the response, this is the wrong way of setting it up. We should then also move the response code into the event listener if we had such a dependency. But it also means that it's super important to understand that with request on or code like HTTP create server, these are some examples where Node.js uses a pattern where you pass a function to a function and Node will execute these passed in functions at a later point of time, which is called asynchronously. Now, it's not always the case that a passed-in function is necessarily executed at a later point of time, but Node.js uses this pattern heavily, and throughout the course, I'll of course let you know when this is the case and when Node executes something asynchronously. In such cases, Node.js won't immediately run that function. Instead, what it does when it first encounters this line is it will simply add a new event listener internally. It manages all these listeners internally. In this case, for the end event on the request, which will be triggered automatically once Node.js is done parsing the request. So this is something Node.js does for you. And it will then call that function for you once it is done. So in the end, you can think of this like Node.js having some internal registry of events and listeners to these events. And a function like this is such a listener. And when something happens, so when Node.js is done parsing your request, it will go through that registry and see, I'm done with the request, so I should now send the end event. So let's see which listeners I have for that. And it will then find this function and any other functions you might have registered for that, and will now call them. But it will not pause the other code execution, and that is so important to understand. So for example, here now, since I moved return response end into this function, the flow is like this. It will now reach this if statement, and if these conditions are met, it will go inside of it. It will then register these two handlers and not immediately execute these two functions. Instead, the functions are just registered internally in its event emitter registry. And then it will jump straight away to the next line. And therefore, right now, if I would restart my server, save the code and restart my server here, you will see that if I enter something here, I actually get redirected to this page, or not even redirected, as you can see. There is no 300 status code. Instead, it just loads this page because it executes these lines. Because, as I now mentioned multiple times, it will not execute this right away, and this return statement will therefore not quit this overarching function here. Instead, it just registers this callback and immediately moves on to the next lines. And it would eventually execute this line, but that is already too late, which is also why we get the cannot set headers error here. because it already moved along and executed this code, when all of a sudden the parsing of the request finished and it executed this code and tried to again send a response, which obviously is too late because it already did here. Now, I know that this is hard to wrap your head around, but it is a crucial concept that you can register code, functions, which run sometime in the future, but not necessarily right now. And therefore, the next line of code, this code here, can run or will run before this code, simply because this is just a callback to be called sometime in the future. And this setup is important because otherwise, Node would have to pause until it's done, pause until it wrote the file. And if it does that, it will simply slow our server down and it's not able to handle our incoming requests or do anything of that kind until it's done. And that is not what we want. We don't want to block our code execution. We always want to be in that wait for new events loop, the event loop, and then only execute code once it's due to be executed and never block that event loop for too long of a time. And this is why we have this setup. And this has one implication for this line and for this line. The implication for this line is that we reach it too early, so to avoid this, we should actually return here. We simply return request on so that this gets executed, but the line thereafter doesn't. And the important implication about this line will be discussed in the next lecture. So what is wrong with this write file sync line here? Well, it's the sync keyword. I earlier mentioned that there also is a write file method, but we used write file sync. The sync here stands for synchronous, and this is a special method which will actually block code execution until this file is created. Now, working with files is available in two modes. Here is the synchronous mode. We block execution of the next line of code until this file is done. Now, for this short of a text we enter, this is super fast and we won't even notice it. But think about a huge file, a couple of hundreds of megabytes or even bigger. If you do something with that, read it, copy it, whatever it is, and you block the code execution, then the next line and all the other code will not continue to run until that file operation is done. And even new incoming requests of other users would not be handled until that file operation is done. And you don't want that. Therefore, you should not use that syntax here. You can if you know you'll only have a very short file operation, but even then, it's better to use this write file method here, which actually does not just accept the path and the data, but also a third argument. And that is again such a callback, so a function that should be executed when it's done. So here again, just as with create server, Node.js implicitly registers an event listener for us. So here I pass another function, and this callback here actually receives an error object, which will be null if no error occurred. But if some error occurred, missing permissions or anything like that, you would get it here and you could then handle it gracefully by returning a different kind of response, an error response, showing to the user that an error occurred, and otherwise return a normal response. Now here, I won't do error handling, and there is really nothing that could go wrong here. We'll of course dive into error handling a bit more later in the course. But I will remove my normal response code in there because this response should only be sent if we're done working with the file, because that is ultimately the action we want to do upon our request, right? So now we actually have our event listener with some method or function that will be executed once we're done parsing the request. And in that function that will be executed sometime in the future, we have yet another event listener, this nested function here, which will be executed once we're done writing the file. And this is actually pretty standard for Node.js. You have this event-driven architecture where you basically tell Node.js, please do something, and it will then go ahead and offload that process to the operating system, which does use multi-threading and so on, and will then continue its event loop to listen for event callbacks, and always just dispatch tiny actions like that to never block the code execution, and then always just come back once an operation is done by the operating system and so on. So this is what Node.js does here and why it is high performant, because it never blocks your code, it never blocks the server, it just goes ahead and tells the operating system, do that, do this, and then eventually comes back and does something in the callback, like send a response, which is not a blocking operation because this is super fast, just a couple of headers and off you go. So I hope this is clear, and with that, let's restart this by quitting the server, rerunning Node app, and going back to just/nothing. Let's enter hello again here and send. And in message text, we see that. Again, concatenated with an extra character, not something we have to worry about right now. So you see, write file also works, but this is the way you should use it due to the asynchronous nature of Node.js, which I hope now became clear, because it is a crucial concept of Node.js and one you absolutely have to understand. With that, let's wrap this module up with these core basics, and let's from now on move to a more easier route where we will make our life simpler and not write all this nitty-gritty detailed code on our own. But it is super crucial that you understand what's going on here. Over the last lectures, I extensively mentioned how Node works with asynchronous code, and I mentioned this event loop, which is important. Let me dive deeper into that and deeper into how Node.js exactly executes your code to stay performant and still be able to handle long-taking tasks like working with files or things like that. Because there is an important concept which you have to understand, well, what is happening behind the scenes. So in our Node application, we have our code. And one important thing to understand and to really keep in mind is that Node.js uses only one single JavaScript thread. A thread is basically like a process in your operating system, you could say. So it's only using that one thread, and the obvious question is, how is it then able to handle multiple requests? Because if we're not able to assign a new thread for each request, they ultimately end up all running in one and the same thread, and this of course poses a security question. Can you then access data from request A from request B? And most importantly here at this point when we talk about performance, there of course also is the question of, does this not mean that if the request A is still doing work, request B can't be handled? Well, both is taken care of Node.js, and at this point of time here, I want to focus on the performance question, though I'll also briefly touch on the security question. Now let's start with the performance. Let's say we have some code which accesses the file system, as we already did in this course too. Now, working with files often is a task that takes longer, because files can be very big and it doesn't necessarily complete instantly. Therefore, if we're doing this upon an incoming request, a second request might have to wait because we're not able to handle it yet, or it even gets declined. So basically our web page is down for that user. Now, one important construct I already mentioned is that event loop. The event loop is automatically started by Node.js when your program starts. You don't have to do that explicitly. Node.js does that when, well, it basically starts running code. This is responsible for handling event callbacks, though. So all these nice functions we basically added thus far in create server, for example, the event loop is responsible for basically running that code when a certain event occurs, you could say. It's aware of all these callbacks and basically, executes that code. That doesn't help us with our long-taking file operation though. And it's important to understand that this operation is not handled by the event loop. Just the callback that we might have defined on write file once it's done. That code will be handled in the event loop, but that code will finish fast. So basically, the event loop will only handle callbacks that contain fast finishing code. Instead, our file system operation and a couple of other long-taking operations are sent to a worker pool, which is also spun up and managed by Node.js automatically. This worker pool is responsible for all the heavy lifting. This worker pool is kind of totally detached of your JavaScript code, you could say, and it runs on different threads. It can spin up multiple threads. It's closely intervened with your operating system you're running the app on. So this is really detached from your code. And this worker pool is therefore doing all the heavy lifting. If you're doing something with a file, well, a worker from that pool will take care and will do its job totally detached from your code and from the request and from the event loop. The one connection to the event loop we will have, though, is that once the worker is done, so for example, once we read a file, it will trigger the callback for that read file operation, and since the event loop is responsible for the events and the callbacks, this will in the end up in the event loop. So there, Node.js will then basically execute the appropriate callback. Now, this is a lot of behind-the-scenes stuff, which is nice to know. You don't have to write any code to make this work. This is all built into Node.js, and if you write code as you learn it in this course, you automatically take advantage of this. I still, of course, want you to understand how that works behind the scenes, because I believe that helps you understand Node.js better. Now, let's look into that event loop then. That event loop is in the end a loop which is run or started by Node.js that keeps the Node.js process running, and as I just mentioned, that handles all the callbacks. And it has a certain order in which it goes through the callbacks. So basically, it's a loop that just, well, keeps on looping, unsurprisingly. At the beginning of each new iteration, it checks if there are any timer callbacks it should execute. We haven't set up any timers yet, but basically there is set timeout and set interval. You might notice from front-end JavaScript too, there these methods also exist. Now in Node.js you can also set a timer, and basically you set a timer and always pass a method, a function that should be executed once that timer completes. And Node.js is aware of this, and at the beginning of each new loop iteration it executes any due timer callbacks, so any callbacks that have to be executed because a timer completes. Then, as a next step, it checks other callbacks. For example, if we had write or read file, we might have a callback because that operation finished, and it will then also execute these callbacks. Now be aware that with I/O here, I mean generally any input-output operations that typically is file operations but can also be network operations, and in general I'm talking about blocking long-taking operations. Now it's important to understand that Node.js will leave that phase at a certain point of time. And that can also mean that if there are too many outstanding callbacks, it will continue its loop iteration and postpone these callbacks to the next iteration to execute them. After working on these open callbacks and hopefully finishing them all, it will enter a poll phase. The poll phase is basically a phase where Node.js will look for new I/O events and basically do its best to execute their callbacks immediately if possible. Now, if that is not possible, it will defer the execution and basically register this as a pending callback. So this is how that works. Important, it also will check if there are any timer callbacks due to be executed, and if that is the case, it will jump to that timer phase and execute them right away, so it can actually jump back there and not finish the iteration. Otherwise, it will continue, and next, set immediate callbacks will be executed in a so-called check phase. Set immediate is a bit like set timeout or set interval, just that it will execute immediately, but always after any open callbacks have been executed. So typically faster than set timeout with 1 millisecond of open duration, let's say, but after the current cycle finished, or at least finished open callbacks that were due to be handled in that current iteration. And now we're entering highly theoretical terrain, and I don't want to dive too deep into that, though you will find a couple of resources that do dive deeper at the end of this module, in case you want to join the Node.js team and really dive super hardcore into this. Now we're nearing the end of each iteration cycle, and now Node.js will execute all close event callbacks. So if you registered any close events, and in our code we haven't, but if you had any close events, this would be the point of time where Node.js executes their appropriate callbacks. So roughly spoken, we have timer callbacks, we then have any IO related callbacks and other event callbacks, and set immediate, followed by close event callbacks. So close events are basically handled separately, or their callbacks are handled separately, we should say. Well, and then we might exit the whole Node.js program, but only if there are no remaining event handlers which are registered. And that is what I mean with this refs equal null thing here. Internally, Node.js keeps track of its open event listeners. And it basically has a counter, references or refs, which it increments by 1 for every new callback that is registered, every new event listener that is registered, so every new future work it has to do, you could say. And it reduces that counter by 1 for every event listener that it doesn't need anymore, every callback it finished. And since in a server environment, we create a server with create server and then listen to incoming requests with listen, this is an event which never is finished by default. And therefore, we always have at least one reference. And therefore, we don't exit in a normal Node web server program. We can call the exit function, as you already saw. And if we do anything else, like at the beginning of the course, when we just used Node to execute a file that did not listen to a web server or on a web server, then it also finishes eventually once it's done with its work. So this is how the event loop works. And this can be very theoretical. All these different phases typically don't matter to you, certainly not when getting started with Node.js. Now consult these advanced resources if you want to learn more. For now, just be aware of that first picture I showed you of how Node.js handles complex work, that there is this worker pool that takes care that your things are not getting blocked, and that it therefore stays performant. Now, I also touched on that security thing with that one JavaScript thread. And regarding that, we also got no problems by default, though I will come back later to how we can manage global data and how we should manage it to ensure that we do not spoil data from request A to request B. By default, we have some separation because remember that callback method in create server, it's executed for every new incoming request, and therefore this function only runs for that incoming request, and anything we do to the request or response object there will not be exposed to other request or response objects because each function is only scoped to itself and not accessible by the other functions. So by default, we have that separation due to how JavaScript works. Now that was a big chunk of theory. Again, not something you have to learn by heart, but something where you should at least keep that big picture in mind of how Node.js manages its work. So let's wrap this module up, and right before we finish, let's actually start wrapping it up by improving our code a little bit. We got all this code in this file, and actually, typically, you write multiple or work with multiple files. And why don't we create a new file that actually contains our routing logic? So the logic where we check the URL and do different things. So I'll create a new file here. routes.js. The name is up to you, and I get this special icon by my IDE. It is a normal JavaScript file, don't be confused. And in that file, I basically want to have my if statements here and my default response code. So I'll cut all of that out of here so that this is a pretty lean file and move it into routes.js. Now, this wouldn't work like that. Let me say that. We'll have to tweak that. But this is now the code moved over. I don't need the file system in app.js anymore, so we can remove that import. We do need HTTP because we still use that there. And we don't need the URL and method here, so let's remove that. Go over to routes.js, add this fs import at the top, and now start working with that. Now, what do we need to do in this file? We somehow need to be able to connect app.js to routes.js, right? Because we need to be able to send our incoming request to that file, so to say. And for that, let's create a new function. I'll name it request handler, and we can either create a function like this. It should receive request and response as arguments, just as this function does, because we'll effectively replace that function. Or we use an ES6 function, storing it in a constant request handler, which looks like this. Bit of a strange syntax if you've never seen it before, but we're essentially creating an anonymous arrow function which we store in a constant, and this therefore is the function name. Now here, we again receive request and response, and in that function, we now move all that code, because that code obviously uses the request and response objects. So we need to have them available as local variables, and we do now because these arguments are now named this way. We also use URL and method, so we need to re-add these constants by getting that data from the request URL and request method. And now we just need to export this handler. We're importing with this require syntax, but how are we exporting in Node.js? There are two ways of exporting. The first one is to go at the bottom and add module.exports. This is another keyword or object which is exposed globally to you by Node.js, which has an exports property, and we can assign a value to this, like our request handler. So this constant which holds this function, it's now stored in module exports. And since this is a global object exposed by Node, Node is actually able to work with this, and we can now import from that routes.js file by requiring it, and Node will look for module exports and see if something was registered for this file here. And we do register something in module exports, the request handler. And you can register anything here. You can add a new JavaScript object with multiple key value pairs, whatever you need. Here, I'll just register my function. So now I can go back to app.js and import my routes. The name of that constant is up to you by requiring it. And since this is now not a global module, we don't just type routes. Instead, we want to add a local path to it with /. And you can omit .js because Node.js will automatically attach this at the end. You can add it though, but I'll just type /routes, separate it from the core modules to make it really clear that this is a custom file. And now Node will go ahead and look for a routes.js file in the same folder as app.js, which it will find. And in that file, it will look for module exports and see what's registered in there. And now we export that request handler method. And now we can use that. It will be stored in that routes because we assign whatever is exported from that file in that routes constant. So this routes constant will ultimately hold this function. And now we can use that here as a handler, routes. Don't execute it, so no parentheses, just pass the name, telling Node, hey, please execute the function that's stored in routes for incoming requests. And now if we save that and we restart the server and we reload this page, this is looking good. And this is also looking good. We should have tests stored in message.txt, and we do. So now we simply split our code over two files, having one file which is very lean, that just spins up the server, but, and that's important, that also creates a connection to another file through that import and through that export, where we export our request handler function here. This is how that works. Now, one important note about Node's module system: the file content here is actually cached by Node, and we can't edit it externally. So if we somehow would define routes as an object and we try to add a new property on the fly here, this would not manipulate the original file. So this is basically locked, not accessible from outside. We can only export stuff that we can now read from outside. Though you could have functions which you export that start changing stuff inside of that file, but let's not make that too complicated for now. We'll see all of that throughout the course, obviously. For now, we have that connection. There's one other syntax you could use instead of module exports. Sometimes you export many things, and you could do that by having an object which has like the handler key, and that is my request handler function. And then also it has the some text key, which is some hard-coded text in this case. Now we would export two things, and that is how you can group that or separate these two things and still have one export being managed here, which is the most you can have. And now in app.js, routes would be that object and not that function. So here we would have to access the handler property. So this property, which holds the function reference we want to use. And we could also simply output console.log routes some text here. So this is how we can have multiple exports in one file. Now you see some hard-coded text here from this console log, and we still have the same functionality as before. Now, there also is a different way of exporting multiple things. Besides this code, which you can of course use, you can also have module.exports.handler, request handler, and then also module.exports.some text, some hard-coded text. Now it might look different, but we still only have one export. We still only have module exports, which bundles all the exports, but we explicitly assign the different properties like this. So this is basically the equivalent to this code. If I now save this and restart my server, oops, we see some hard-coded text. And if I submit this, it also still works. And last but not least, there is a shortcut for this syntax. You can now omit module and just write exports. This is simply a shortcut supported by Node.js, not some general JavaScript magic. It's just an explicit shortcut supported by Node.js, where now we also have multiple exports being merged together into one export. So therefore, again, when I execute this, we see some hard-coded text and some last value being submitted here. Still works and still ends up in message.txt. So this is how we can connect multiple files by exporting either one element, one function as we had it initially with module.exports equals request handler, right? This is what we had initially. Let me comment this out with two slashes in front of it. Or module exports pointing at an object to combine multiple things, or using module.exports.handler equals request handler and module.exports.some text equal some text. Or again, this shortcut, which is the same as this, just with this shortcut offered by Node.js. So this is how imports and exports work, how the module system works, and will work with a lot of files throughout the course. So this is important to understand. With that out of the way, let's now finally wrap this module up. So let's sum this module up now. First of all, we had a brief refresher on how the web works, and in general it looks like this. Client, so the browser, sends a request to the server does some magic, reaches out to a database, works with files, sends back a response, can be HTML, can be something different, and sends it back to the client, the browser, which then can display that. And that is the entire flow we also saw in this module. Now, Node.js is the part that runs on the server. And regarding its life cycle, there is one important concept, and that is that so-called event loop. Node.js code runs in a non-blocking way, which means we only register a bunch of callbacks and events, and Node.js will eventually trigger that code once a certain task is done, so that the JavaScript thread is always free to handle new events, new incoming requests, and stuff like that. A Node program can exit if there is no more work to do, but on a server this, should at least never happen, because create server registers an event listener for an event which is never done. If a new event is triggered, so if a new request is received, this does not mean that Node unregisters the event listener. Instead, we keep on listening for more requests, and that is of course how a server should behave. So it's this cycle that's important to understand, and that we have this loop which always keeps on going, keeps on waiting for new events, and which does something when some event happens, and then basically dispatches some actions to the operating system, you could say, for example, and then again frees up the thread. Now, this also involves a lot of asynchronous code, which we saw with all the callbacks. The JavaScript code should be non-blocking, so we have this callback and event-driven approach where we are able to register some code to be executed in the future instead of running right away and blocking the main thread, because this has to be avoided under all circumstances, and Node.js is built around that concept of avoiding this issue. We also saw how to work with requests and responses the Node.js way. We saw that we have to parse the request data, which arrives in chunks, and that we can use this concept of streams and buffers, which I explained, and that we should avoid sending double responses, so that after res end, you must not send another response. And this can happen easily if you forget about that asynchronous nature and that a line of code you write might not execute immediately. So depending on where you write it, if it's in an event listener, it will not execute immediately. That is what I mean, and that is what is important to keep in mind here. We also learned that Node.js is all about using its built-in functionalities. And whilst there are some global variables or objects or functions we can use, this also means that we should use its core modules. Core modules are things like the HTTP, DFS, or the path module. There are more, and you can learn all about them in the official Node.js docs, of course. We'll also use quite a lot of them throughout this course. And these core modules give us a couple of different functionalities that allow us to basically do whatever we ever could want to do on a server, like create a new server with the help of the HTTP module. They're imported via the require syntax, and we can only use them in the file into which we import them. And if we want to use them in two different files, we have to import them in both files separately. Now that leads us to the Node module system, and this basically works with the help of this require keyword, which pulls some functionality from one of our files if we start with / or ./, or from a core or third-party module. We haven't used any third-party modules thus far, but we'll also do that soon. And it basically pulls in whatever we export there and stores it in a new variable or constant, as we did it in this module. And export is an important keyword here. We do export with the help of module.exports, or for multiple exports with the exports shortcut I showed you in the last lectures. So this is what we learned in this module. And I know that this was a lot of theory or nitty-gritty stuff about Node.js. Doesn't look too easy and beautiful, but it'll get way more beautiful from now on. It is super important to never forget what Node.js is and does for you though. because many courses right away start with Express.js, which we'll also use starting soon, and therefore you never really learn what's happening under the hood, which is sad because this is important and makes you a better Node developer. But with that, let's move on. Now that we already had a pretty close look at Node.js and worked a lot with it, let's take one step back and let's see how we can both make development a bit easier, how we can speed that up a little bit, and most importantly, how we can actually debug our Node.js apps, or how we can use various tools to understand better what's going on in our Node.js applications. Because in this module, you will learn some tips and tricks which will hopefully help you write Node.js applications in a very efficient manner. For this module, I'm back in the application or the project we worked on in the last course section. And you can find my state attached to this video so that you can start right at the same point as I do. So it is just the code we wrote over the last lectures. And one thing we constantly had to do in the last section or throughout this course was that we always had to run Node app.js to start our app or our Node application with that file. Now, this is certainly okay and not too much work, but it actually is possible to define some scripts in a Node.js project that can help us with tasks like this. We can also use them for other tasks, but especially for this, they can be useful right now. And for that, we have to use a feature we didn't use thus far. We have to use NPM. NPM stands for Node Package Manager, and it is installed together with Node.js. So you don't need to do anything, you got this installed already. Now we will also use NPM to install some additional third-party packages to our project soon. So packages that are not included in Node's core, so not part of Node's core modules. But we can also use NPM to initialize a so-called Node project or to add some extra features to it, to be precise. Because we obviously already got a Node project here, but now in this project, in a terminal navigated into this project, you can run npm init. Now, this will not delete your code or anything like that, no worries. Simply hit enter and you'll be prompted with a couple of questions here. It'll ask you first of all for a name of your package. And for now, you can simply translate this with project name. Now, you can pick any name you want. The part in the parentheses here always is the suggestion, the default it will pick if you don't choose your own name. So if I just hit enter here, it will take that default. So you can basically do that for all these questions. For the description, you can leave that empty. Then it will have no default text either. But you can also enter some text like complete Node.js guide. This is what this course is. And then define an entry point with app.js, for example. You can leave the test command empty. Leave that empty. Keywords, you can choose some if you want. You can put your name into the author field, though this is also not required. And you can also choose a license, but if you don't plan on sharing this project publicly, this also doesn't really matter. So with this, what you get is this package.json file. And there you also see all these settings or configurations you just set up. And you can, of course, edit them there too. So if you had a typo in your description, you can just edit it here. Now, this is using the JSON format, which is a special kind of data format, which basically looks a lot like JavaScript objects. And it pretty much is based on that. There's one important thing to understand, though. The keys are always put between double quotation marks, and so are the values, except for numbers or arrays or true or false, which are not put between these. But that's too much for now. We can ignore that for now, just so that you understand what you got there. It's basically a configuration file for your project. Now, what does this configuration file give you? Well, let's clear the console here. With this configuration file, you see that we got a scripts section there, which has one default script that won't do anything for now. You can add your own scripts here, and I will tell you how to execute them too, of course. For that, let's add a comma after this test script and add a new script name, which has to be put between double quotation marks. And there, let's name it start. Now, start is actually a special script name, as you will see in a second, so make sure to type this correctly. And then between quotation marks, you type a command that should be executed. So this is a command which you could also type down there. And there we always had to type node app.js. So let's now put that between these double quotation marks here. Node app.js, like this. With that, save that file. And then you can run npm start. Start is a reserved name, and this will always look for such a start script here. And if you do that, it will, as you can see here, just execute node app.js. So it does the same you had before, but now you can always just, well, run this command instead of running node app.js. Not that much of saved characters, but a few at least. And it's also good practice because if you ever share this project, it's pretty common that people just have to run npm start and that they don't have to guess which of your JavaScript files is the entry file. So you can quit this with Ctrl+C, of course, as always. And I mentioned that this would be a special script name. You can add more scripts also without using a special name. You can indeed choose any name you want. Just make sure that you always wrap the name in double quotation marks and that it does not contain any blanks or white spaces. So for example, we could have start-server. Now this can also run node app.js, so it will do the exact same as this script, and therefore it's of course redundant, but I want to show you something. And now, if you try running npm start-server, you'll get an error. You basically get an error that this is not a known command. And indeed it isn't, because just typing the script name here will not work. Start just was a special case, as I mentioned. Indeed, for normal scripts with your own custom names, you have to run npm run and then your script name. So npm run start server will now also start the server. Now, as I mentioned, this is of course redundant. npm start is way shorter, but I want you to understand how you can add your own scripts. Now, if you worked with something like Angular or React or Vue or any modern front-end development workflow, you will have seen that you use such scripts a lot to trigger build workflows for your projects, for example. And indeed, you can use that for all kinds of tasks you want to execute, but for now, we'll not dive deeper into that. And if you haven't worked with Angular or React, that's also no problem. You will see what I mean later in this course when I explore Node's functionality as a build tool a bit more. For now, let's just use that npm start script to start our application conveniently. So in the last lecture, we added a script to start our application, and this is nice to know that we have this scripting functionality. Now, with such a package.json file available, so therefore with this being a managed Node project, you could say, we can also do one other very important thing. we can install third-party packages. Because a typical Node project looks like that. You have your local project with your code, obviously, and you use a lot of core Node packages, like the FS package or the HTTP package we're already using. But often this does not suffice, and in the next course section we will install one big third-party package actually. Because you typically have such dependencies, third-party packages. So you want to use some functionalities, some code, which you didn't write on your own, but which is also not included into Node.js. Packages could help you with parsing incoming requests, validating user input, anything of that kind. Now, we will use Express in the next lectures, or in the next module to be precise. Body Parser is another package we'll use throughout this course. And there are thousands of packages available that offer all kinds of utilities you can add to your projects so that you don't have to reinvent the wheel. These packages are available through the NPM repository. That is a cloud package repository where all these packages live, and you can conveniently install and manage them via NPM. Remember, that tool that shipped with Node. And this is exactly what we will do now to install a first little utility package that will speed up our development workflow. Because right now what we have to do is, whenever we change our code, we have to quit the development server with Ctrl+C and restart it, right? So if we have it running with npm start now, remember this is our new command to start the server, and I would change something here. Like, for example, here I fixed that /head, right? Whenever I do this, I have to save this, and for my change to have an effect, I have to quit the server with Ctrl+C and restart it. Now, this is a bit cumbersome, because we just want to be able to type and then hit save, and it should automatically restart then, right? That would be a great workflow during development. And to achieve this, we have to install a third-party package that gives us just this functionality. Now, how do we add such a third-party package? We do that with the help of npm. And there we get the install command. So just as we had run to run one of our scripts, install installs a third-party package. Now, how do we install it? First of all, we have to know the package name. And if you're wondering, well, how do I know the package name? Well, that comes with courses like this, Experience, or by simply Googling for certain problems which you want to have solved, and all of a sudden you find a thread where some package is mentioned. Now I can tell you, for this auto restart mechanism, there is a package called nodemon, written like this. By the way, you can always search for npm and then the package name if you know that name. And you will find an entry on npmjs.com. Now this is the package page basically, where you find a description, installation instructions, usage instructions, how to configure it, because most packages give you an easy way of using it and then always give you configuration possibilities. You see how popular the package is, what version it's using, if there is an external homepage, where the source code can be found if it's open source. So you find a bunch of stuff here. Pretty useful. You also see how many versions are existing, and by default you will always install the latest version, by the way. But let's go back to installing it before we dive deeper into this whole npm thing. So we want to install it, and this command would install it, but don't hit enter yet. You can define how this should be installed, because packages which you install can be divided into development packages, so packages which mostly help you during development, and production dependencies, so packages that help you for the app as it's running on a server. For example, nodemon would be a development dependency, because we only use it during the development process. Once we install our app on a real server, we don't need it there. The real server, which is running somewhere in the internet, of course shouldn't restart, and it also doesn't have to, because we'll not change its code dynamically. And you can basically tell npm which kind of dependency this is. This does not make a huge difference, and you can omit this setting, but it helps you understand which package is used for what. Now you do add this by adding --save--dev. If you had just save like this would install it as a production dependency, so a package which we really use in our code and work with. And with this, we're indicating, this only adds something we use during development. There also is a third option, by the way. -G will not install it in this project, but globally on your machine so that you can use it anywhere. Now, let's first of all install it with save-dev, like this, --save-dev. Now, what this will do is it will download it from the npm repository and install it into this project. So not globally on your machine, but into this project. So now you see you get a report here that it finished successfully what it did, and it gives you a couple of new things in your project. It gives you that node modules folder, the package log.json file, and it updated the package.json file. There we see that the new dev dependencies section was added, and that stands for development dependencies. As I said, you can differentiate between different dependencies. We'll see production dependencies later too. And there you see that NodeMon was installed and which version was picked. Now, regarding that character here, well, this basically defines how this package will be updated if you rerun just npm install without defining an extra package name. Because this command standalone will simply go through all your packages mentioned in package.json and install them, and it would automatically pick a later version if available. But more on npm and packages can also be found in a separate module later in the course. So this is basically how we now installed this. And the question is, where is it installed? Well, that is the node modules folder. And actually, that is a huge folder, as you can tell. The reason for this is that, for one, we got NodeMon in there. If we look for N, we see it here. Now, this is basically the source code of the package, or the build version of the package we installed. And this package simply happens to have a couple of peer dependencies. You can see them here and here. So we got a bunch of dependencies in there, and these and their dependencies are also installed. That is why you quickly end up with quite a big node modules folder. But you can always delete that node modules folder if you need to free up space. Now you can't use that package, but you can then rerun npm install if you start working on that project again, and it will reinstall this package and all its peer dependencies, and therefore recreate the node modules folder. This is how packages work in node projects. So you need that node modules folder whilst you're using the packages, but if you're not working on the project, you can delete it if you want, if you need the free space, and then just remember to rerun npm install once you're working on the project again. The package log.json file, by the way, just stores the exact versions I installed today, so that if you share your project with others, they can actually get these exact versions too, instead of the latest versions. But again, more on npm in a separate module. So for now, we got that NodeMon package installed, and it will just work because it automatically installed all the dependencies this package needs in turn. So how can we now use it? Node1 is a utility tool, and it allows us to run our application, our Node application, through this package here, which will run Node app.js in the end, but which will also watch our files for changes and restart the process for us if we do change something. So we can simply change start here, so the Node app.js command, to NodeMon app.js. And this will look for a NodeMon tool, which it will find in this project because we installed it here. As a side note, if you were to run NodeMon app.js down there, you would get an error that this command is not found, because it's only installed in this project and not globally on your machine, but the terminal will try to find this globally. Here, it will work because this will look globally. So if you now run npm start, this will simply start the Node server and output some extra information. And if you now go to your routes.js file and edit something, let's just add an extra line, and you save that file, you see it's restarting. And this, of course, is very convenient because now we don't have to spend time on manually exiting and restarting. Now this is done for us. In the last lectures, we worked a bit on the project setup and how we could use external packages, which is super important and which we'll do a lot throughout this course. But now I want to have a look at something else which helps us during development, and that is, of course, fixing errors. We need to understand how we can find and fix errors in our code because there always will be errors. You will never write a program that just runs perfectly. For this, we first of all have to understand that there are different types of errors so that you can understand how each type can be tackled. The first kind of error you often get or you sometimes get in your programs are syntax errors. This is if you have a typo in your code or you forget like a closing curly brace or anything like that. So you have an error which should automatically be thrown when you try to run your project. Most of the time these are pretty easy to fix, but we'll have a look at this and how we find and fix them in a second. The second category of errors are runtime errors. At least this is how I like to call them. Now these are errors which are not typos, but where you try to execute some code which will just break when it runs. And I'll show an example for this in a second too. The third kind of errors are logical errors. Now these are the most difficult ones because there you will never see an error message. Your app just doesn't work the way it should. And it can be hard to find these, but I will also show you some tool which can help you with that in this module. So let's now start with syntax errors and let's see how we can find these and fix these. Syntax errors can be very annoying, but most of the time they're not that hard to fix. Let's add a simple syntax error. Here in app.js, let's simply remove the t in const. Now all of a sudden, this is an invalid keyword. It doesn't exist, it's not a keyword. And we already get some help in the IDE, which is showing us something is wrong here. Now if we hover over this, we see that a semicolon is expected, and actually this is not that helpful. This is simply because Visual Studio Code thinks that this is a variable, and since we have a variable in the same line, we should close this with a semicolon. And now it actually doesn't show an error. But let's save this, and let's try running our app with npm start without that semicolon being added. And you will see it right away crashes, and in there we see unexpected identifier cons server. So in the end, whilst it doesn't clearly tell us that we forgot the t here, because it's not smart enough to understand that this is the error here, we still see that the error seems to be stemming from this line. And in such cases, as dumb as it sounds, you should simply take a closer look at this line and see what could be wrong there. And you should quickly be able to see, I forgot a t here. So these are syntax errors. Other errors would be that you maybe go to the routes.js file, and let's say you forget a closing curly brace here. Now again, Visual Studio Code does complain and does show an error over there. If we jump there, we see at the end that the closing curly brace is expected. Now it's not expected at this point where it's showing this message, but it's expected somewhere in the file. And whilst it can be cumbersome, you should then check your block statements, like this if statement, and see if they're all closed correctly. In Visual Studio Code, you also get some help because if you click next to such a curly brace, you see that this line gets highlighted and it actually shows you where it thinks that this is getting closed. And this is far too much at the bottom here, for example. Again, if you run this, you will see that it crashes. And there you also see unexpected token, and it points us at route.js, and then you see the line number 2. So here it points us at line 52, and it basically shows us the same place as Visual Studio Code, which is the wrong place. But in such a case here, you should really take the IDE help, see that error message, and then go through your file and see, where could I be missing a character? Or where do I have an extra closing curly brace or something like that? And eventually, you should be able to find this error and therefore, of course, fix it. So syntax errors should always result in an error message, and then it can sometimes be hard to find them. Often it's like a typo, a mistyped variable name of a variable that therefore doesn't exist, or missing or extra characters. But you can find them, and it just takes some time to go through your file. The next category are runtime errors. And a great example for this can be shown with the res_write method here. Now, as I mentioned, you have to return here to prevent the execution of the code after this statement. Otherwise, and this is something node specific of course, you would end the request here, but the code execution would continue, and eventually we would reach this line. And this is no syntax error, this is correct. But if we run our code here, it seems to work, right? There is no syntax error after all. But if we now visit our page, eventually it breaks here. And this is the point where you should go back to your code and should find an error message there too. And this error message is something you shouldn't just take and paste into the Q&A section, but actually read it. A lot of the error messages are indeed helpful. You just need to know how to read them. At the bottom, you always find uninteresting stuff, I'd say. But you have to scroll to the top of the error message, and all of a sudden, it should get more meaningful. For example, here, you see the error code, which already indicates that it's something with headers being sent. And then here, you actually find a detailed error message. Cannot set headers after they are set to the client. And then you see that it was caused by a call to set header, and unfortunately the line numbers don't help you, here at least, but then it does help you here. You see it's in the request handler, and there it points at the route.js file, line 32. And now this is the point where you can dive in and see, okay, I'm calling set header here. Now since it's complaining that I can't set them after they are sent to the client, I should look in the code before this statement, because it looks like I'm finishing my response there for this example. And indeed, at some point you should find this statement and see, I do actually not finish my code execution after this statement, which is not per se a problem, but it becomes a problem if in the following code I then work on my response again, as I'm doing it here. So now this is the point where we can fix this by stopping the code execution, or by wrapping this in an extra if statement, which is guaranteed to not run if we make it into this statement. And now with that, we can of course restart our server, or actually we don't need to, we got NodeMon now, so you don't need to do that. And now if you reload your page, it will work again. Now, the third kind of error I want to discuss is the logical error. And that is often the most difficult one to fix, because it will not cause an error message. Your app will just not behave the way you expect it to. Let's see here in the routes.js file where we parse our body. We're retrieving the message here. And that is of course nice, but let's say I actually do have the first element being stored in message here. And keep in mind, the second element, which we previously had, is the actual message the user entered, because we're splitting that key value pair we're getting automatically, and now we're actually storing the wrong element. So now if I save this and my server restarts due to NodeMon, I can enter some test here. And if I do this and I open my message text file, I actually see message there. Now, this is a logical error, because we got no error message, but the app is not behaving the way we want it to. Now, of course, we know that we used the wrong index here because I just changed that. But let's say you worked on that code for the first time and you just used 0 here because you forgot that this should be 1. So you didn't change that back on purpose, but you really made this mistake. Now, it's not super obvious to see. And how can you now work on such errors? Well, with the help of the Node.js debugger, which actually has a great integration into Visual Studio Code, which I strongly recommend using. Let me show you how that debugger works then. For this, let's quit that process. And let's select the app.js file now, that's important. And now go to Debug here in Visual Studio Code in the menu and choose Start Debugging, or use the keyboard shortcut you see there. Now with that, you have to choose an environment, and there you should use Node.js. And you will now see that extra bar here at the top, which allows you to control the debugger. You see the red bar at the bottom that indicates that you're in debugging mode. And you actually also have a debug console here where you now see that the debugger is attached and listening. Now, what does this mean? This means that now you actually can look into your code as it's running. But to really do that, you need to set so-called breakpoints. So let's go to the route.js file. And let's say we assume it has something to do, our error here with the wrong text being stored, with this code snippet, because ultimately that is where we write it to the file. So what you can do is you can set a breakpoint in Visual Studio Code by going to the left of the line numbers until you see that red dot and clicking there. Now we got a breakpoint there. And what will now happen is that with that debugging process running, don't quit this, you can quit it by clicking the red square, but let's leave it running. If you now submit some text here, it should automatically jump back and mark this line like this, highlight it yellow, and kind of put this yellow arrow around our breakpoint. This means that the code execution now stopped here. It did not continue, it stopped, and it stopped so that you can look inside of it. And actually, you can now analyze your code in the moment it's running. For example, you can hover over your variables to see what's stored inside of them. So for example, you see that the parsed body is this string, which we're splitting in the yellow highlighted line. You see what's inside of the body you pass to concat, that it's an array with a buffer of length 12, for example. You can even expand this to look into it a bit more and find more details about the buffer in case you're interested here. You also can go to View and then Debug here. This gives you a special debug mode where you see the key variables you have available in your code right now. Message is undefined because we stopped in that line where we would set it, but it stops before it executes the line, so therefore message is still undefined at this point. But parsed body, for example, does hold the value, well, it has, which you can also see if you hover over it. You don't just see local variables, which are available in this function, but block variables too. This is the variable which is also available outside of this function. It's this variable, and you can also look into that therefore. And you can generally click around to see some global values and the values they currently have stored, and a couple of these things. You also can define watchers here. For example, you can click a plus here and then watch message and hit enter. And now you will always see that here. You also see it up here, but if you ever close that, you can define some variables you're particularly interested in and watch them whilst you go through your code. And you also see your breakpoints down there. You see all the breakpoints you set. You can uncheck them here to not stop execution the next time they are reached, and so on. You also see the call stack, which looks very cryptic, but which in the end just shows how the process went through your code. And you can click on these different parts to see where actually this code, which belongs to the code that was executed, can be found. And not all of that is code you wrote, a lot of that is core Node.js code. Okay, so that's the debugger in a nutshell. Now to work it and to continue with your code execution, you can use that panel here at the top. You can resume code execution with the play button, but we don't want to do that. Instead, we want to step through our code step by step so that we can see when it fails or where it goes wrong. And you can do that with this button, which steps to the next line basically, or with this button here, which doesn't just step into the next line, but actually even goes into functions like this one. So if you click here, and again, now all of a sudden you're in the right file function defined by Node.js. You can step out of there with this key. Now you see, if you continue here, that this wasn't too helpful, but that we can now navigate like this in our code. So now let's make this more helpful. And for that, let's try this again and use the debugger properly now. We'll do this in the next lecture.